improve. All right, so understanding check. We just still need to look at, we finished 9, right? We still need to talk about 10, 11, and 12?
Yeah.
Thank you. All right. So I've given you a function here. Domain and range. Okay, first off I want to say this. I'm not spending 10, 15 minutes on this one problem. I will go over a couple of quick details that we need to pay attention to. The reason why I will not, and some of you probably already have this note, and if you don't have this note, you know you need help with this. We covered a problem just like this last Friday when we went over the last understanding check. So if you go check out the video from April 1st, 2022, which I don't think I put 2022 in there, but April 1st from this class on YouTube, we went over details about all these different things. We all good with that?
Yes.
Okay. So, I'm going to start with the easiest one first. E and F, X and Y intercepts. Number one mistake. Well, first off, there's a handful of us who weren't able to identify X and Y intercepts. We got to fix that. Okay, so we're going to talk about one detail. Secondly, when you write about an X and Y intercept, what should you always write? Should you write X equals 3? No, what do you need?
Points.
A point. Okay. You need to write a point for your X and Y intercepts. Make sure you do that. Also, I saw a couple of people do for Y intercepts X equals -8. Can anyone explain to me why that would be incorrect here?
Because that's a 0, not a, and it's not.
So I think they're referring to this point.
So they should have 0.
I mean,
So, well, the Y intercept, the X is not -8, the Y is, but even there, you should have written it as a
Yeah.
point. Now, you will get credit, and some of us got some credit, but more of us should justify. What's a really quick thing you could have done to show your X and Y intercepts?
Mark the graph.
Right. So Jakeem, you're asked about how we justify. Something that could have been quick is to note X intercepts. Right? Just like that. You don't have to write a lot for that. Right? And then one here. And then here, Y intercept. Done. Now, that's probably going to look at a 5. What do you think you would need to say for a 5.5 or a 6?
Cos of x and cos y is like
Yeah, the idea of explaining y, and just like Chloe said, the x-intercepts is where the function intersects the x-axis. The y-intercept is where the function intersects the y-axis. That's it. Don't make it more complicated than that. Right? Questions, comments, concerns? Take one, you rocking with that? You good? Alright.
Man, this kid.
I'm sorry you feel this way.
What are you doing?
Alright,
Turn it down.
so, yes ma'am. What?
It's already cold.
I'm anemic.
Wear thicker clothes.
I mean, I got a jacket on, but still, I'm already
Okay.
cold.
I'm sorry that you're already cold. I am not. So,
Change that.
I can't. Look, you can always put more clothes on, you cannot always take clothes off. Let's be real. Okay?
So you're the cold type of guy. You'd rather be freezing than right.
You wear shorts and
Yes.
turn the breeze.
It's already cold.
Yes.
What?
Wait.
That's so bad.
Okay. Relative max and min. We already addressed this a little bit earlier. A lot of us correctly identified the points that were relative max and min, right? This point right here being a relative minimum, thank you, and this one being a relative maximum. So what could you have done to justify why that is a relative minimum?
It stops decreasing, it starts increasing.
So one way to say it is it stops decreasing and starts increasing. Sheridan, is that what you were going to say?
Yeah.
Okay. Does anyone know another way you could have identified that as a relative minimum? It's the lowest value of that section, right? Very simple. That's how we would justify that there. However, whether it's relative max or min, should you have written 2.69, comma 8.4? Is that what I am looking for your final answer?
No.
Does anyone know what we should have written here?
No, I didn't do it for real.
Relative maximum of, just like we talked about on number 3, relative maximum of what?
2.69.
2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2.69. 2 Not 2.69. Keyshawn, I need you focused, not looking at your fingernails or your tickets or whatever that is. Remember, huh? I did. I did. I
Oh my
don't
God.
remember, but I need you
Where
to
did it go
focus.
tonight?
Okay? So, remember the maximum or the minimum is the Y value. It's the output. So it's of what? Of 8.4. That's the notation you should have said. Relative maximum of 8.4 at
Oh,
at what?
at 2.69? No.
What is 2.69? That is the x. At x equals 2.69.
Oh,
And
okay.
it's the same concept for relative minimum. That's the notation that I'm looking for. Because minimum and maximum, or minima and maxima, that's the plural for it. It's of the outputs, it's of the Y values, right? It's the lowest and the highest. Right? That's a Y idea.
See, I was.
And it's at an X value. Right? Domain of f of x and range of f of x. The first thing that all of us should have written down for domain and range, what does domain refer to? The x values. Or the inputs, right? The range would be the
Y value
or the outputs.
Yes, sir.
Right, right?
and
Yeah.
not the input.
So we want to recognize that, and that's a quick detail that we should have added. Jakeem, are you paying attention so you can get this information? I appreciate the work, but I'm telling you, this would help you, okay? So we want to pay attention to that. That's a quick, small piece of justification. Now, you need to remember, we're going to use interval notation. And so whenever you do interval notation, and I saw this mistake a lot, what comes first in the interval notation? The minimum comes first. Then the,
Max.
and you know what I saw a lot of?
Maximum.
Saw a lot of this.
What? That don't really make sense.
That's on, which one?
Could that, it doesn't matter, I saw it on both actually. But why could it not be infinity comma negative infinity?
Because it don't work that way.
That's
Minimum to
That's
max.
maximum
It's
minimum.
max to
right
minimum.
That is a maximum value, that's a minimum value. On the left should always be the smaller value.
there. Negative.
Period.
So for this problem, right, for domain, negative infinity. Now why is it negative infinity? Because the graph continues to the left, right? It's going up, but it's also going to the left, to the negative infinities in the x, and it's also going down, but to the
Right.
right.
Yes, sir.
So the maximum x value would be
Positive.
positive infinity. Even if you're not doing a great job writing this down, which I appreciate some of us are, where can you find this information later?
YouTube videos.
On YouTube videos, right? A lot more detail on these things for last Friday. We're not going to go into why, but range would have also been negative infinity to infinity. What I want to focus on for just a second is the domain intervals of increase. Does anyone remember what I said would be the first thing I would do when identifying domain intervals of increase and decrease?
Oh, this is what I needed.
Uh-huh. I would identify it on the graph. When I read a graph left to right, what is this function currently doing? Decreasing. Where does it stop decreasing?
Right there.
What's that point called?
The relative minimum.
We want to notice it's relative minimum. The whole point of a relative minimum is it stops decreasing and starts to
Increase.
So couldn't I, as part of my evidence, circle and write that it's decreasing here?
Yes, sir.
And then what does it do after that?
Starts increasing.
Notice how it increases all the way to this relative maximum.
Yes, sir.
And then what does it do afterwards? Decreases again. That's a lot of important evidence. You're showing me that you at least understand where it's increasing and decreasing, even if you don't get the notation correct. That's important to notice. Now, there's a reason why I word it this way. Kiani, you awake with us? Can you get up, stand by your desk, so you can take notes better?
I'm good.
Can you
My
do
eyes
some jumping
just
jacks?
irritated.
Huh?
My eyes just irritated.
Oh, okay. So, please pay attention to this. What does it say right here?
Domain,
Domain intervals, right?
X,
So we're only talking about the x values when we write it.
yes.
So, here as well, we are only talking about the x values. So when I look at this section of decrease, what is the lowest x value, the minimum x value where it starts to decrease,
Negative infinity.
right? It starts all the way over here to the left and all the way up, and it's decreasing all the way through. So the lowest x value is negative infinity. And it goes all the way to negative 13.8, right?
Oh,
Okay,
Is that correct?
I got that.
Yes?
yes, that's
We
correct.
sure?
No.
I see why I messed up.
Wait,
Yeah.
wait. No, we're talking about X in
Because
itself,
I
right?
put the X.
Hold on.
We're talking about X in itself.
I asked, is this correct?
Wait, no, that's not correct.
It would be negative
So
one.
I got
no.
the X values.
Oh, I need the domain, I can't go to the y values?
So you messing me up.
No, I'm asking you to think. Y'all are just used to the teacher telling you the right answer all the time instead of actually thinking about it.
I said yes.
KT's like, yep, that's exactly what I'm used
I
to.
said yes.
So we want to notice something like that. I bring that up, and I will point out, how many intervals of decrease should you have had?
Two.
Two. So there is another one we need to do here, but I saw a lot of people on the increase say from negative 13.8 to 8.4. And those are the y values. That would not be correct. I need the x, the negative 1.36, all the way up to 2.69.
Oh, okay. That's what comes.
What are your questions before we continue? Tyrese, can I get you to put your headphones up, please? All right, if there's no questions, we're continuing on. Now, numbers 11 and 12. Couple of really important details you should pay attention to here. And you should all make this note. Right here, you see where it says dilate h of x by x minus 2 in order to graph? Anytime I'm asking you to graph the dilation, I'm asking you to graph it accurately, which means you need to make a what? Table. Anytime I'm asking you to dilate and then graph, you need a table to accurately graph. I'm not asking you to look at the calculator. You can use the calculator to check yourself, but you need to show clear evidence of your understanding. So, one of the things that I would point out, and we kind of looked at this in the bell ringer yesterday, I feel like a lot of us, when we're making our table, we're just kind of putting things in here, right, for like the next column. We're not really paying attention to what we're trying to get to. At the very end, right, or let me say it this way. If you're going to get on the road and you're trying to drive somewhere, you need to know where you're going so that you figure out how to go from the beginning to the end, right? You can't just magically take left turns and right turns and hope that you get there. You got to know where you're going. In the same way, I'm starting with x's. By the end, what should I have?
The dilated function.
The dilated function, which is f of x, but how are we getting f of x? H of x.
H of x times x minus 2.
So yeah, that's the dilation. If that's what I'm trying to get to, I actually only need two columns. You can split up more if you want, but does anyone know what the first column I need is?
H of x.
I need h of x, right? That's it. I need h of x,
And x.
which is 2x plus 4 times x minus 2. And what else do I need?
X minus 2.
Anybody want to push back on that or ask a question about that? So if I multiply h of x by x minus 2, will I get the dilated function? Heck yeah. Now we do need to pay attention to how we're going to get those x values. What's the first thing we need to do to determine the x values we should use?
Identify the zeros.
Right? So ID zeros, you'll get more practice on how to do this later, but the zeros are -2 and 2. Now it's important to recognize that this was a double root or it has a multiplicity of 2. Yeah? So -4, -3, -2, -1, 0, 1, 2, 3, and 4. So 2 quick things, because I want this to be so much easier than most of y'all are making it. Yes, can I substitute these x values in? Yes. And remember, I will point out, in the calculator, remember how you can scroll up and highlight an expression you've already done and hit enter and bring it down so it can speed up your process? I would take advantage of that. But better than that, okay? Let's say I'm looking at h of x, but I have an x value of -3. How can I use that graph to get the output when x is -3? Anyone know? Huh? How can I get my output, right? That's my input. How can I get the output for h of x when x is -3? I can substitute, but I'm asking about using that graph.
Look at the point.
Oh, look at the point.
Look at the point. There's an x value of -3, right?
Mhm.
Hey, what's the y value for that?
10.
I don't even have to substitute anything in.
Oh, wow, that's so easy.
And you can check it, right? So 2 times -3. I wouldn't do this, I just want you to see that it does work. Right? 2 times -3 is -6. -6 plus 4 is -2. -3 minus 2 is -5. What's -2 times -5?
10.
No way.
No way.
So beautiful.
It's like Mr. Kenny's never said that before. Oh, wait.
Wow.
Wow. Wow. It's not magic, it's math. Patterns and relationships, okay? It is magical.
Math is magic to some degree.
No, so magic implies that someone's trying to trick you or,
Can be tricky.
it can be tricky, but no one's trying to trick you. We gotta find those patterns and relationships, right? So 0 and -6 and -8. Notice we can just go to the graph for most of those. And that's it. Now I want to caution you, because I saw a student doing this earlier today where they wrote the number 8 right here. Anyone want to take a guess how they got this 8? Now we'll say it's wrong, but how did they get 8?
Oh, no.
They subtract
10 minus
2 from the 10.
They did 10 minus 2. But remember, it's supposed to be
X minus.
x.
So it's -3 minus.
-3 minus 2 is -5. -2 minus 2 is -1 minus 2 is.
-3.
We should start to notice a pattern.
Yeah.
And there should always be a pattern.
One.
It's adding by 1. Because, hey,
Oh, yeah.
what type of function would this be? Linear.
Linear.
And what would be the slope of that linear function?
Constant additive.
Well,
One.
specifically a 1.
Yeah.
Right? Constant additive by 1. Right? That pattern should exist. And we can take advantage of that. And then I just do the dilation. And finally, for number 12, and then we're going to get back to working within our small groups. The last detail in number 12 is this. I asked you to write f of x in factored form, which we kind of already did that a little bit. Remember, that's h of x, and we did a bell ringer on this yesterday. But remember, h of x was this expression. Right? That's the factored form. How are we going to multiply all the factors? How am I going to multiply those factors out?
You can use the
I
table.
need it, hold it.
It's not called a table, it's called the,
Distributive property.
you can use distributive property or
Area model. There you go.
the square, right? The area model is what that is.
A square.
Now, I want to point this out. Let me check something real quick. Yeah. That should be later. It's supposed to be that. Okay, so we can use area model, we can use distributed property. Are there lots of places to make mistakes there?
Yes.
Heck yeah. So how could you check yourself to see if you did make a mistake?
Graphic
Graph
on the
What?
calculator. Graph
the,
the function.
well, remember, it's only one function, hopefully.
The dilated.
The- What is this called? What form is this?
Oh, the factor form.
Factored form. You can graph the factored form and the standard form.
And see if they overlap.
See if they overlap. And
They overlap is right.
Sheridan only made a small mistake in her process of multiplying, but she's the only one who followed that note of, hey, if you realize you made a mistake, let me know. And she looked at the calculator and saw that they did not map on top of each other. And so she showed me greater understanding than, okay, I made a procedural error, but I know that this isn't right. And so she earned a higher score than if she had just done it and made a mistake. Be aware of that, right? I'm looking for understanding. If you show me, hey, I know I made a mistake, and I know it because of this, then you're going to earn a higher score because you're showing me greater mastery of the content. So be aware of that. All right, we're going to get back to the practice. And so again, we are working with each other, developing the skills. One thing I would do if I were you before I leave today is I would tackle numbers 1 through 4. These are very conceptually based questions that are fundamental to everything we do. Now, one last thing I want to point out is this. 5, 6, and 7. Notice how it asks you to write a function in factored form. That would be the product of the functions given in the graph. Yeah, remember that? See it? So, don't you need the equations for these different functions? Earlier this year, did we study how to write the equation of a line or the equation of a quadratic? Yes, Mr. Kenny. Thanks, guys. We 100% did. And some of us struggled with it. If you did not master content, this is a chance for you to improve your understanding, because I don't care when you learn it. I care that you learn it. If you failed any previous quarter and you're struggling to pass, but you use this opportunity to learn and grow from your mistakes, bet I'll honor that. I care that you learn it, not when you learn it. Okay, so if you failed, you're not out of the hunt yet. Let's learn, grow together, and help each other learn. Let's get to work. John, your eyes okay? I saw you looking at the reflection surface.